Thank you. 14.2. Addition, a lot to write here, and subtraction, equations with integers. So we're shifting up our objective a little bit. These are not two-step equations. We're back to solving one-step equations now. The only difference this time is with negative numbers. Next year, in Chapter 2, though, you'll be solving two-steps equations with integers, positive and negative values. So, Dom, let's stop whatever you're doing.
Okay.
Distracting everybody else. So next year, and starting in Chapter 2, next year, we spend, the first chapter is just adding and subtracting with integers. You won't have your calculator. Second chapter, do it all with equations. Third chapter, inequalities. Fourth chapter, all the same thing, except now you'll do it with decimals, positive and negative values. And then chapter 5, all the same thing yet again, but with fractions. And then chapter 6, that'll be about the third quarter when we get there. Then you'll have your calculators and move on to percents at that point. So basically you'll get 5 chapters of working with negative values next year, a whole half a year solving equations, two-step equations. We'll introduce decimals, fractions, positive and negative fractions, decimals, no calculators. Anyway, we certainly covered negative numbers earlier this year. Where was it? Chapter 5? Yep, Chapter 5. So, if you're so inclined, you have your notebooks here, but if you need a refresher, and I'll give you a refresher, but feel free to check out 5.3, what you did with adding integers. That's what it looked like when we did it back in the day here. Here we are, solving equations with negative values. This is the same thing that we're pretty much going to be doing today. There it is. Here we are, solving equations with negative values. So, in a sense, we did exactly what we're about to do here in 5.3. Right there. There it is. Boom. 5.4 was your subtraction. One of the differences you probably notice is the numbers are slightly bigger nowadays. A lot of single-digit action going on here on this page. Now we got a whole lot of double-digit action going on. So I don't know if that's a huge upgrade in difficulty, but 5.3 and 5.4, and again, specifically, these 9 problems here, 21 through 29, are exactly what we're going to do today. I don't know in your homework if they have these types of problems. They probably do, but feel free to check. 5.4, 27 through 32, subtracting equations, boom, there they are, with negative values. So, we've kind of done this before. There will be combining like terms. Notice 12 through 16 all have different like terms going on there. Call that pregame work. Before we can solve the equation, there will be work to do to these problems here to simplify the equation. Only once it's simplified, only once we've done our pregame, only once we have combined our like terms can we move on to the solve the equation stage. So 1 through 11 or 3 through 11 are all ready for us to solve right off the bat here. And that's great. So before we do anything here, I'm going to review the 2 rules of addition. Again, you have your calculator in front of you. That can certainly help you, but next year you won't have your calculator when you do this type of work. If you're doing a MAPS test, I doubt they'll provide a calculator to you for these types of problems. For some, but this won't be a situation where they would. So what you need to know is you need to know the 2 rules of addition. We covered them earlier this year. So there is no rule of subtraction. We rewrote subtraction problems as addition problems by adding the opposites, and then we solved them applying the 2 rules of addition. And we're going to do that again for some of these equations here to show you that technique and method here, to focus on the two rules of addition. So, two rules of addition. And again, I wrote these out in 5.3, no doubt for you, but they need to be reviewed. The sooner you memorize them and get them, the easier your life will be next year, chapters 1 through 5. So I literally can, every year with 7th grade, I've gone through them, and even by January, 5 chapters, 2 and some odd quarters worth, and people still can't figure it out and do it right. So it's always a little frustrating to me that when I get to January with 7th grade and people still can't figure out how to add and subtract with negative values. Sig? So the sooner you get this, I'm telling you, this is the whole ticket to your first 2 quarters. Once I see you next year here, technically that's in 11 days, right? 11 days, because 10 days here, and then the 11th day, whoosh, you'll be back here, right? You know, not counting weekends or days off type deal, but in 11 days we'll be back here, and this is what we'll be talking about. So 11 days, right? Truth. 11 days, right? 11 school days, right? You'll be back here, and this is what I'll be teaching you. So 11 days from now, so not that long. Okay, so first, rule 1. If the signs are the same, add the values, and carry the sign to your final answer. Okay, first rule. If the signs are the same, and what I'm talking about here is if I have a positive plus a positive or a negative plus a negative. So I'll give you a couple examples here of how this would work here. But if the signs are the same, 2 numbers. If the signs are the same, add the values and, not are. If the values are the same, add the values and carry the sign to your final answer. So here in 6th grade world, once again, this isn't how they show it to you in 7th grade here, but this is how they did it back in chapter 5. Notice how they clearly designate, and we talked about this back in chapter 5, that I don't typically write all these little pluses all over the place here, right? Unless it's marked otherwise, you just assume the value is positive. So this one is a negative 29, but I wouldn't really write that positive 69 there. I mean, unless it's marked negative, the number is positive, okay? So what am I saying here? If I got 2 values, let's say 6 plus 8. And again, I'll just do it this way for the moment here. But I should be able to look at this problem and realize both of the signs are the same. I'm adding a positive to a positive. Signs are the same. So what do? I add the values together. 6 plus 8 is 14, and then I carry the sign. When I say carry the sign, I'm saying whatever the sign is, these 2 things carry over. My answer is a positive 14. Okay? This works the same with 2 negative values. If I had negative 7 plus a negative 4, and once again, I realize that the signs are the same. They're both negatives. Negative and negative. So what do? Well, I add the values together. I'm not even considering the sign right now. I'm just adding 7 plus 4. 7 plus 4 is 11. But then, what are my signs? They're both negative. Therefore, negative 11. So when the signs are the same, 2 positives or 2 negatives, add the values. Technically, you're adding the absolute values together, and then carry the sign over. Okay? So usually signs the same isn't too much of an issue with people, but when the signs are different, I don't know what happens here. Things tend to get more difficult for some reason. So if the signs are different, And I'm basically saying if I'm adding a positive and a negative value, or a negative plus a positive, however you want to think it, if the signs are different, here's what you need to do. Subtract the greater absolute value minus, I'll write it this way, otherwise I didn't write it right, the lesser absolute value, then carry the sign from the value with the greater absolute value. It's kind of a mouthful. And again, I totally get it why people sometimes struggle with it. But again, in 7th grade, after 4 months of doing it, you should be able to figure it out eventually. I mean, there's only 2 rules here. So,
I think we did this a lot last year too, didn't we?
in 5th grade, yeah, our last chapter, the 5th grade are just about to start. It was our last set of lessons there. Chapter 14, we did integers, right. And again, chapter 5, we did them in this year, and now we're seeing them once again, and next year we'll do them all year. So if the signs are different, I'm talking about adding a positive to a negative value or adding a negative to a positive value, you need to use your subtraction, even though it's an addition problem. You'll use subtraction to solve. You need to figure out the absolute values. Anybody remember what an absolute value is?
The value without a negative or a positive. Like
That is true. What does an absolute value technically represent, though?
The number.
But it represents something. Represents how far
It is on a scale.
a number is from 0 on the number line, is what it does. -7 and +7 are both 7 spots away from 0 on a number line, right? So that's what absolute values represent. They're always represented as positive values. Because -7, +7, how far is that away from 0 on a number line? It's 7 spots away. I don't say it's -7 spots away, I just say it's 7 spots away from 0 on a number line. So that's what absolute values represent. So if I had a +9 plus a -3, okay? And I should be able to identify the signs are different. One's a positive and one is a negative. So what do I need to do? And again, you don't necessarily need to write this step out here, but to illustrate what's going on here, if you remember, there's our symbol for absolute value box. Remember that?
I remember that.
So that's the absolute value box symbol there. Absolute values are always positive. So the absolute value of +9 is 9. Absolute value of -3 is 3. But you always want your greater value on top, the greater absolute value. In this case, the absolute value of +9 is greater than the absolute value of -3. But when you do this subtraction problem here, you should always come up with a positive number. Always. I mean, always. So what's 9 minus 3? 6. So my answer is either +6 or -6. It's one of the two. And how do I know? Well, then you go to this part right here. Then carry the sign from the value with the greater absolute value. Which of these two had the greater absolute value?
9.
The 9. And what was the sign attached to the 9?
Positive.
A positive. And that means that my final answer should be a +6. So I found the absolute values. Whatever the greater absolute value is on top, whatever the lesser absolute value goes on bottom. Perform your subtraction problem with normal positive numbers, 9 minus 3. Should always get a positive answer at this stage, but that doesn't dictate is my answer positive or negative. Nope, Now you got to go back and look at basically whatever was on top here, your bigger number, whatever sign that has, that's the sign that comes with you to your final answer. If I had negative 8 plus positive 2. So same deal. I would look at these, I'd realize, oh, my signs are different here. Okay, I need to figure out the absolute values of both. Do you need to write it this way? Probably not. I'm just illustrating to you what's going on here. But what I would do is go, this is the greater absolute value. Absolute value of negative 8 is positive 8. Absolute value of positive 2 is 2. 8 is bigger than 2. Therefore, 8 minus 2 is 6. Second, is it a positive 6 or negative 6? And it goes back to which one was the greater absolute value. Whatever number you had on top is your greater absolute value. What was the sign attached to that absolute value? A negative. So I carry that sign with me. Answer should be negative 6 this time around here. All I did was look at my absolute value. Whatever sign is attached to the greater absolute value is the same sign that I will use in my final answer. Always. Always. And again, basically I just did this once again here. And then 8 minus 2 is 6. Greater absolute value always on top, negative 6. Yes?
Yeah.
Okay. So again, the sooner you could wrap your mind and understand this, again, we did it. If you remember all this and you're like, yeah, I got all this, I remember all this, makes sense to me, well then, congratulations. You'll have a pretty not so horrible first 5 chapters of 7th grade, and that's great. Makes my life a lot easier too. If you can wrap your mind around this, but again, every year people struggle. We'll go through it again next year, over and over and over. So, knowing all that here, let's look at number 3. And again, we'll talk about subtraction problems in a minute. But I got R plus, and then generally, and again, we talked about this before. I'm writing it slightly different here, my negative values. The book here doesn't use these brackets all over the place like I'm going to use, but anybody remember why I'm putting these brackets in there?
Because it's not R plus minus.
Right, because if I wrote it this way again, this would make no sense whatsoever here, right? You would have no idea what exactly you're supposed to do with that there. So generally, this is how, when negative values are around, it's very common to put them in brackets to make sure that you're not having some order of operation confusion going on here. Your book, again, writes it in a slightly different way, but I'm writing them in a different way just because this is not the norm here. This is not how you will see it in 7th, 8th, 9th, 10th, outside of the rest of 6th grade, this is not how you'll see these written. So I want you just to get comfortable with how you're going to see these written in the real world going forward here, and this is how this would be done. So I'm going to write things the way they should be written. I'm not going to write all these little positive things all over the place here. I'm going to write it like you will see these problems normally. Okay? So we are solving equations here. And again, you need to kind of open your mind here and think about what's the opposite here. Now, addition and subtraction function as opposites. I could rewrite this whole equation another way, because when we start talking about our subtraction stuff, I'm going to tell you to rewrite as an addition. I'm going to say, anybody remember the magic 3 words? Add the opposite. Right. So if I rewrote this, adding a negative 7 is the same thing as subtracting a positive 7. This and this are the same thing. Adding a negative is the same thing as subtracting a positive. they are totally interchangeable pieces here in how you do it. Why do we do that? Well, a lot of times for subtraction, to get back to the rules of addition, we want to rewrite subtraction problems in addition form. That way we're clearer on what our signs are. Oh, signs are the same. Oh, signs are different. But you got to get in an addition form here. So then you just flip the signs around. Subtracting a negative, same thing as adding or subtracting a positive, same thing as adding a negative. Boom. Now I can just shift to my two rules of addition and I know what to do here. But this is one and the same. Adding a negative 7 is the same thing as subtracting a positive 7. Either way, how would I undo this step here? What do I need to do to solve this equation?
Subtract positive 7 from both sides.
If I kept it in this form here, and again, we understand doing the opposite. So undoing addition, adding a negative 7. So I could think about this a couple different ways there. What is the opposite of adding a negative 7? Subtracting a negative 7. I could think about it that way here. But this creates a double negative situation here, which is fine. Because double negatives, again, go back to what I said, the 3 magic words. Add the opposite. So if I turn this to an addition problem, I'm adding, what am I adding? What's the opposite of negative 7? Positive 7. Because think, I'm subtracting a positive 7. If I wrote it this way, what would you do? I would add 7 to that. If I said r minus 7, you would say add 7 to both sides, right? Positive 7, because you're undoing a subtracting 7. So subtracting a negative is the same thing as adding the opposite, adding a positive. Okay, and you can think about this however it works for you here. There's some different avenues here. But ultimately what I'm doing here is either subtracting a negative 7, that's a double negative. When we're doing equations and stuff, that's one of the things you'll clean up before you start solving. You'll rewrite all your double negatives as adding positives. That's part of your pregame work you'll do with equation stuff. But basically, I'm adding 7 to both sides here. However you want to cut it, the opposite of subtracting a positive 7 or the opposite of adding a negative 7, subtracting a negative 7, adding the opposite is adding a positive 7. No matter what, your path leads to adding a positive 7 to this thing here, to undo adding a negative 7. Negative 7 to the left, offset by adding 7 to the right. Boom, now we're at 0. Yes? So this is canceled out. My solution is whatever negative 19 plus 7 is. And again, you should recognize that the signs are different. Negative value, positive value, greater absolute value is 19, lesser absolute value is 7. 19 minus 7 is 12. Positive 12 or negative 12? Negative 12, because the greater absolute value was a negative value. R equals negative 12. If I check it on my calculator or whatever, go back in, negative 12 plus negative 7 equals negative 19. Rules of addition, signs are the same. 12 plus 7 does equal 19. Carry the sign. Two negatives, negative outcome.
So should we use that setup to do every problem? No.
You need to undo, show your one-step process here. Different people do it different ways here. Let's look at number 4. Somehow, though, you need to undo. So this one says y minus a positive 85 equals a negative 74. It's basically y minus 85 equals negative 74. So what's the one move I need to do to undo my equation?
Add 85.
Right. The opposite of subtracting a positive 85 is adding a positive 85. Right? So I would add a positive 85. So negative 85 or subtract 85, add 85. That's gone. Add the 85 over here. Greater absolute value, signs are different. Lesser absolute value, I get 11, positive or negative?
Positive.
Positive, right, because the greater absolute value in this case was the positive 85.
That makes sense.
So carrying that over here, y equals positive 11. 11 minus 85, or plus a negative 85 if I add the opposite. Signs are different, right? So greater absolute value, subtract lesser, gives me 74. Carry the sign from the greater absolute value. Negative 74. That's right back to where I started this thing when I plug in positive 11 into the equation. Why don't you guys try, well, let's look at number 6. So it says G minus a negative 17 equals positive 39. So in this case here, you can think about it a couple different ways here. I am subtracting a negative 17. What is the opposite of that? Adding a negative 17. But
You have to keep the.
I can do it, again, I can do this two different ways. It depends how you want to think about it. What is the opposite of subtracting a negative 17? Adding a negative, because subtraction and app function as opposites. So I can go about this way here. This will cancel these out here. Subtracting a negative 17, adding a negative 17. However, when you have these negative, double negative situations here, it makes a lot of sense to resolve them, because having these negatives all over the place, more than you need, makes things more complicated. And when you get a double negative situation is when you're subtracting a negative value. We go back to the magic 3 words where I should rewrite this in addition form. So my subtraction becomes addition. What do I add? I add the opposite. What is the opposite of negative 17? Positive 17.
So if there's a double negative like that, you can change the problem to G plus 17.
That's what I do. That's my, but other people like to do it this way.
So then you subtract.
They stick hard and firm to doing the opposite. The opposite of subtracting is addition. What did I subtract? Negative 17. How do I undo that? Add a negative 17. They do the opposite. So both of these work. Both of these will get us to the same spot here, where, again, adding whatever value to itself will cancel it out. We'll cancel it out. But either way here, I am subtracting 17 from both sides. If I write it this way, the opposite of adding a positive 17, subtracting 17. The opposite of subtracting a negative 17 is adding a negative 17. So look at the end here. Either I got 39 plus a negative 17, or 39 minus a positive 17. But they're one and the same, right? Would you agree with that? Subtracting a positive is the same thing as adding a negative. They are identical. It's just the path that you take. How do you want to view this type of problem? And I'm not saying one way is better than the other, but I personally resolve double negatives as soon as I possibly can, because they just, as things get more complex, I mean, you want to simplify things to the simplest form possible. Working with double negatives is not simple. It makes things more confusing, especially if there's other negatives throughout the whole equation that you have to consider too. How do these things all come together? If you're dealing with 5 different negative symbols of all different types here, that's very difficult to know how to add and subtract different things unless you simplify it all. Simplify the whole thing. So, my opinion, this is the way I go. When I see a double negative, anytime I see a double negative, where's another double negative here? Right there, number 10, double negative. I see Q plus 29 here. That's what I see. I don't see minus negative. I see plus. That's kind of about it. We'll have to look at that there. But okay. So either way, your solution is 39 plus negative 17. G should equal a positive 22.
Oh, let's go.
In the end here. And if I go into my calculator, punch it in, G is 22. 22 minus negative 17 equals positive 39.
Let's go.
So when I test it on my calculator, it works out. 22 minus a negative 17 is the same thing as 22 plus 17. Double negatives. Add the opposite. And you can do that with any subtraction problem at all. Every single subtraction problem you can write. I'm going to move this on just a little bit here. I mean, we're already in slightly overtime, but oh well. Let's look at number 12. So you'll have a few word problems once again to do, 15 through 18. But I want to do 2 more. Again, I'll try and review some tomorrow. So n plus 13 plus 15 equals negative 75. And this time here, no matter what you do, you're going to want to combine your like terms first. So what do I want to do first to solve this equation?
Add 13 plus 15.
Right. Any order of operation that's on the same side of the equation should always be simplified first. And I can add 13 plus 15 right now. What's 13 plus 15? So I got n plus 28 equals negative 75. So now what would I want to do?
Now, you would want to subtract 28.
Subtract a positive 28, but subtracting a positive 28 is the same thing as doing what? Adding a negative 28. And why did I write it that way? Well, what do I know about these two signs now?
What?
They're the same, so therefore I should add or subtract these values. I should add the values together and then carry the sign. What's my final answer?
Negative 103.
Negative 103 is what this equals here.
So if it's 2 negatives,
When I subtract a positive, I'm subtracting a positive 28. Subtracting positive 28. But the opposite of subtracting a positive is adding a negative, right? I turn my subtraction problem into an addition problem. And why did I do that? I did it because now I can see that actually the signs are the same. Right? Subtracting a positive 28 is the same thing as adding a negative 28. And I did it in that form because now I can see that these two signs are actually the same. I'm adding the two values together with same signs. Negative 75 plus negative 28 is the same thing as negative 75 minus a positive 28.
that makes sense.
So I'm converting my subtraction to addition here, and I'm doing that to see which of the two rules of addition I need. Are the signs the same or are they different? I'm trying to pivot off subtraction if I can and convert it back into addition. And I do that to figure out which of the two rules am I going to use. Am I adding the values or subtracting? All right, last one here, and then we got to go. Number 16. And we're out of here, so. So this time, we have brackets in play. And PEMDAS tells us whenever we have brackets, we should always do that order operation in brackets first. So the first thing you're going to want to do is solve this problem here. What's negative 30 plus 76? And you're going to be subtracting that sum. And then see if you can finish the equation.
Yo.
So negative 46 equals z minus. And again, all I've done here is whatever I'm doing is contained in the brackets. Yes?
Yeah.
This is what I'm doing right now. But notice what I did on the left side here. I would look up and at least see what I wrote here. It'll help you. But all I did, nothing is going on with anything over here. So everything that I have outside of the brackets, I've just copied, including this subtraction sign. This really matters a lot because when you're subtracting and negatives are around, for whatever reason, these subtraction signs tend to just vanish in the wind sometimes here. But I am subtracting whatever this is here. So I want to make sure, and I'm ultimately going to get a positive number here, but you don't want to lose track of this subtraction symbol. You don't. So negative 30 plus 76, signs are different. 76 minus 30 is 40. Greater absolute value is 76. There it is there. And then from this point, again, I could rewrite it if I chose. Z plus a negative 46 if I wanted. Subtracting a negative 46, that's now I've created a double negative. But that's the same as adding a 46 or subtracting a positive 46. I would undo by adding 46 to both sides. Z equals 0. Z equals 0. Okay. So homework 1 through 18. Don't get too bent out of shape about 1 and 2. In fact, if you just want to skip 1 and 2, I don't care. Do 3 through 18. 3 through 18, all right? I will review a few with you tomorrow.
Mr. Melcher.
It is not, no. My house is, you'll know